Welcome to True Projects. In this video, we are going to explain about a project titled Predicting the Student Academic Performance Using Deep Neural Network Using Real-Time Dataset. Education stands as the foundation of progress and it's crucial to comprehend and enhance the student's academic performance. To pave the way for the brighter future, in this pursuit, we embark on the advanced and the innovative journey, harnessing the capability of the deep neural network to develop a sophisticated predictive model. Our primary focus is to utilize a comprehensive data set that encompasses various academic variables, enabling us to gain the valuable insight into the factors that influence the student's success. Our project's core objective is to revolutionize the educational analytics by accurately forecasting the academic outcome, identifying the student, and providing the personalized intervention to optimize their learning experience. By employing the data-driven decision-making and the cutting-edge machine learning technique, we aspire to empower the educators, educational institutions, and the policy makers in fostering a more effective and inclusive education system that caters to the need of all the students. The predictive model we develop using the deep neural network will be capable of analyzing and interpreting the complex pattern and academic data, providing the valuable guidance for the educators to make the informed decisions. Through this informative approach, we aim to create an environment that nurtures each student potential, fosters a love for learning, and ensures that no student is left behind. The main goal of our project is to leverage the advanced deep neural network to develop a highly accurate predictive model for the students' academic performance. We aim to explore and compare the difference of the various machine learning algorithms, including logistic regression, random forest, naive-bayes, SVM, voting classifier, and the deep neural network, in the task of predicting the student academic outcome. Our project focus is on rigorous training and optimization of the deep neural network to ensure its effectiveness in forecasting the student future academic achievements. By utilizing the power of the machine learning and the deep learning technique, we aim to identify at-risk students who require the additional support and provide the personalized intervention. The ultimate objective of this project is to revolutionize the educational analytics by empowering the educators, educational institutions, and the policy makers with data-driven insights. The project's significance lies in its potential to contribute to the advancement of the education, ensuring that all the students receiving the support and resources they need to excel academically and achieve their full potential. These are the basic requirements that are needed to build this project. Software requirement: Python IDEL with version of 3.7, Anaconda with version of 3.7, or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. To know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this step, essential Python libraries are imported, such as Pandas for data manipulation, Cbun for data visualization, sklearn for machine learning algorithm, and TensorFlow for building neural networks. These libraries provide the necessary tools for this project. And the second one is importing the dataset. The dataset containing the student's academic performance is imported. It included the various features such as of roll number, problem solving and programming, linear algebra and calculus, engineering graphics, and of many more. The datasets serve as a basis for the training and evaluating the predictive model. And the third one is data visualization. Data visualization techniques are applied to explore and understand the dataset pattern, distribution, and the relationship between the variables. Through plots and charts, data visualization helps in gaining the insight into the data, identifying the potential outliers, and understanding the distribution of the academic performance score. And the fourth one is building the model. Here, the first one is logistic regression. Logistic regression model is implemented to predict the class label of the digital logic design based on the academic performance data. Logistic regression is a linear classification algorithm that is well suited for the binary classification task, making it fitting choice for this project prediction problem. It works by fitting a logic curve to the data, allowing it to estimate the probability of the student's success or failure in the digital logic design based on their academic performance. The simplicity and the interpretability of the logistic regression make it an effective model for this classification task as it provides the insight into the relationship between the input feature and the likelihood of the success in the subject. And the second one is random forest. Random forest is an ensemble learning method that combines the multiple decision tree to enhance the classification accuracy and the generalization. In this project, each decision tree in the random forest is trained on the different subsets of the data and their predictions are aggregated to make the final prediction. This ensemble approach reduces the risk of overfitting and improves the model robustness. By combining the prediction from the multiple decision tree, the random forest classifier can effectively handle the complex relationship in the data, allowing it to provide the accurate prediction for the student's performance and the digital logic design. And the third one is naive-Bayes. Naive-Bayes is a probabilistic algorithm based on the Bayes theorem, which calculates the probability of a particular class label given the input features. It is commonly used for the test classification, and in this project, naive-Bayes estimates the likelihood of a student performing well or poor in the digital logic design based on their academic score. Despite its assumption of the feature independence, naive-Bayes can provide the accurate prediction and is computationally efficient, making it suitable for this classification task. And the fourth one is SVM. It stands for Support Vector Mission, is created to predict the digital logic design label, where it is a powerful algorithm for the binary classification task. It works for finding the optimal hyperplane that separates the data point of the different classes in the feature space. SVM aims to maximize the margin between the two classes, leading to the robust prediction for the new data point. SVM is particularly effective in the high-dimensional feature space and handle the complex decision boundary. By finding the best hyperplane to differentiate the student performance, SVM provides the accurate prediction for the digital logic design outcome based on the academic performance data. And the fifth one is voting classifier. Voting classifier combines the prediction of multiple individual classifiers including logistic regression, random forest, naive-Bayes, and SVM. This ensemble method leverages the collective wisdom of the different models to achieve the better accuracy and the performance. By averaging or taking the majority vote of the prediction from each classifier, the voting classifier benefits the diversity of the individual model, reducing the bias and improving the overall prediction accuracy. And the voting classifier enhances the project's robustness and ensures more reliable prediction for the students' performance. And the last one is deep neural network, is to build the powerful model capable of learning the complex pattern and the relationship in the data. By utilizing the multiple layer of the interconnected neuron, DNN can capture the intricate feature and the representation, making them suitable for the more sophisticated classification tasks. In this project, the DNN leverages its ability to learn the hierarchical representation of the academic performance data, allowing it to make the accurate prediction for the students' performance and the digital logic design. The deep architecture and the flexibility of the DNN enable them to handle a wide range of data and achieve the state-of-art performance and the various classification problems. And the fifth step is accuracy comparison graph. After training all the model, the accuracy is compared using the appropriate evaluation metric. And the next step is training the model. The selected best performing model is trained on the dataset using an appropriate training algorithm. The model learns from the input feature and to make the accurate prediction for the class label. And the next one is user gives the input. A Flask web interface is set to allow the user to input the academic performance, including the features of like problem solving and programming, linear algebra and calculus and statistics and many more. And the next step is the given input is pre-processed for prediction. The user input provided through the Flask interface is pre-processed to prepare it for prediction. Pre-processing involves the tasks like scaling the input data to the model's requirement, feature engineering, and handling the missing data. And the next step is trained model is used for prediction. The pre-processed user input is fed into the trained model. The model processes the input data and make the prediction with the class label where the digital logic design based on the academic performance data provided by the user. And the last one is final outcome is displayed. The prediction result from the model is displayed to the user through the Flask interface. The outcome includes the predicted class label based on the input academic performance data. This displayed the information aimed to provide the valuable insight for the user's academic progress and the potential in the subject of the digital logic design. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder containing of the various files within it. The dataset folder containing of the dataset that we used in this project. It contains of the various columns and of rows as of like this, like field of problem solving and programming, linear algebra, engineering, graphics, and of many more. And the static folder containing of the CSS, fonts, assets, images, and the JavaScript folders within it. And the template folder containing of the HTML document like of home, index, notebook, result, sign in and sign up pages within it. An app is an py file which likely contains the information related to the front-end logic. It includes the code written in Python that handle the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the model.pickle file is a file containing of algorithm information loaded into the project code during the runtime to utilize the trained model for the various tasks such as making the prediction on the new data or performing the specific operation. And the notebook is an IPYNB file which contains a combination of the code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And to execute the project, we build a Flask framework as a front end. For this, we need to copy this address of the code folder and then open the Anaconda prompt. Here we need to write a command F. By this, it will change the location of the disk to F. And then write a command cd space and paste this code folder path. By this, it will change the directory to the code folder's path. And then write a command that is python space app.py. By using this command, it will execute the Python script and perform a runtime check for any syntax errors or the logical issues. And then after running the app.py file, the Flask framework will host the application locally at the default address as like this. We need to copy this local link and paste it on any of the web browser, and I prefer to use the Google Chrome. Pasting this local link and then click on enter button. We redirected to this page of containing the home and the sign up buttons within it. Click on sign up button and we redirected to the sign up page containing of necessary details we need to be filled for creating an account. But my account is already generated, that's why I'm using the sign in button. Here it redirected to the sign in page. We need to enter the detail as of admin for the username and password too. And then click on submit sign in button. Here it redirected to the index page containing of submit button and some input details that are need to be filled. And here we can see that A represents of 0, B grade represents of 1, C grade represents of 2, D grade represents of 3, and E for 4, and F for 5, and S for 6. and we need to enter the grade for the problem solving and programming as 0, that means of A. A linear algebra and calculus as 6, that means S. And the engineering graphics as of 0, that is A. And the Python programming as of 0, that is A. And the data structures as of 0, that is A. And the probability and the statistics, that is 6, as of S. And then click on submit button. Here I've redirected as you will pass in the digital logic design. In this way we will predict the student's performance, and we can re-enter the other details as of 0 for problem solving and programming, linear algebra and calculus as 6, and the engineering graphics as of 5, and the Python programming as of 0, and the data structures as of 0, and probability and the statistics as of 6. And then click probability and statistics as of 6. And then click on submit button. Here at redirected you will file in the digital logic design. And this way we can predict the students' academic performance using the deep neural network using the real-time dataset. And this is the accuracy comparison graph, where x-axis represents the score of each accuracy for each algorithm, and the y-axis represents the algorithm's name that we used in this project. And in conclusion, our project has successfully achieved its objective of developing a powerful and accurate predictive model for the students' performance by leveraging the deep neural network architecture and a dataset encompassing the diverse academic variables. We have gained the valuable insight into the factors influencing the students' academic performance. The trained model demonstrates the impressive accuracy in forecasting the future academic outcome, identifying at-risk student and suggesting the personalized intervention to optimize the learning experience. This project's significance lies in its potential to revolutionize the educational analytics, empowering the educator, institutions, and the policy makers to make informed decisions and offer the tailored support to the students, thereby fostering a more inclusive and effective education system. Moving forward, our work contributes to the ongoing efforts to enhance the student academic success and create a brighter future for the next generation through the power of advanced machine learning techniques. Thank you for watching.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.